video, we want to talk about two important concepts in probability: mutually exclusive events and the addition rule for probability. So what do we mean when we say two events are mutually exclusive? Basically, they're mutually exclusive if they can happen at the same time. So let's look at some examples. Basically, if the occurrence of one precludes the occurrence of the other. The occurrence of one event precludes the occurrence of the other event. So if I look at event A would be in a given year, let's say 2000, in the year 2020, the Houston Texans win the Super Bowl. And event B, the Cleveland Browns win the Super Bowl, which probably will never happen. I think people in Cleveland agree. Those are mutually exclusive because if one happens, the other can't. If the Browns win, then the Texans can't win and vice versa. Okay, so these events are mutually exclusive. Okay, now if I look at event A, the Dow Jones goes up 20% in 2020. And event B, Microsoft stock goes up, let's say at least 20%. Goes up at least 15% in 2020. Well, those could both happen. I mean, the Dow could go up 30% in 2020 and Microsoft could go up 20% in 2020. So they could both happen. So now we want to talk about how do you find the probability of A or B. Okay, that means A happens, B happens, or both. Okay, now the rule is you take the probability of the first event plus the probability of the second event minus the probability they both happen to avoid double counting. And to see why you have to do that, let's look at a simple example. Here we have 12 points in our sample space. You can see 4 times 3. And so we can let the red X's be event A, orange is event B, and notice A and B are not mutually exclusive because they can occur together. There's a red and an orange here, and event C is blue. Okay, now if I want the probability of A or B, how many points would give us that? Well, basically, there are 1, 2, 3, 5 points, right? 1, 2, 3, don't double count this. You get 5 points. And so if you apply the rule, the chance of A would be, let's put this over here. Okay, so what you would get is the probability of A here, okay, is the X's, that's 3/12. And then you take the probability of B, the orange, that's 3/12. And if you stuck with that, you'd be wrong because you'd say 6/12, and there's only 5 points. But the probability of both is 1/12. And so then you get the right answer, which is 5/12. Okay, but now if A and B are mutually exclusive, A and B, then the last term drops out because they can't happen together. Then the probability of A and B is going to be 0. And so our rule simplifies for mutually exclusive events, the probability of A or B, you just add them. Because we look at events A and C up above, C is the blue, are mutually exclusive. So the probability of A or C, looking there, that would mean an X or a blue, okay, that would be 3/12 plus 2/12. So nothing to subtract, and that's perfect. Okay, so let's try some more complicated examples. "50% chance it rains on Saturday. And a 50% chance it rains on Sunday. Is it sure to rain on the weekend?" Well, we want raining on the weekend would mean that we want the probability of A or B. It rains on Saturday or on Sunday. So that would be the probability of A and plus the probability of B. Okay, but that's going to be 1, but you have to subtract off the probability it rains on both days. And see, that's greater than 0. So you'd have 0.5 here plus 0.5 minus something. And so something greater than 0. So you'd have 1 minus something greater than 0, and that's less than 1. So it's not sure to rain on the weekend unless you live in Seattle. That's a joke. Okay, now another example. You throw 2 dice. Again, dice can come up 1 through 6. What's the chance you get at least 1 4? Okay, well now basically you could say, if you look at all the outcomes for a dice, we can see the answer right here. There's 6 ways you can get a 4 with the first die of 4. And then there's 6 ways, if I make this a different color, 6 ways you can get a 4 in the second dice. So you might say 6 plus 6 is 12 over 36, but you got to subtract the case where you get 2 4. You get both 4s. So the probability, okay, if we a 4 on first die or second die, would equal 1/6 the chance of getting on the first one plus 1/6 the chance of getting it on the second one minus the chance of getting on both. Is there's 1 point out of these 36 that would give you it on both. Now this row is not relevant there. Clear the format. Okay, so you'd have to subtract off the 1 chance out of 36 that you would get it on both, and that's 11 divided by 36. Okay, so that concludes our discussion of mutually exclusive events and addition rules for probabilities. In the next video, we'll go on to the rule of complements.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytic stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.